Hey, hello. Welcome to yet another talk. My name is Viktor. I work for Shippa, and today we're going to talk about progressive delivery, continuous delivery, or continuous deployment, and quite a few other things. GitOps, yes, right? Random stuff. Actually, not random stuff, but a lot of things, and they're all somehow connected. And you will see soon how and why and when. So let's start with the basic thing. We all want the same thing, right? Actually, we want many of the same things, but one of the things that we all want that's to deploy our applications in a way that it is easy, it is fast, it is repeatable, it is reliable, it's traceable, and secure. I'm yet to find a person who says, no, I don't want one of those things. I mean, nobody wants to go slow, nobody wants things to be hard, and so on and so forth. Now, in 2021, the ways how we would accomplish those goals, how we would make deployments, all those things might be slightly different than what we are used to. And to get there, to be really fast and easy and all the stuff, we need a couple of things. To begin with, we need to remove people from the process because people are antithesis to repeatable, right? We cannot repeat the same thing over and over again. Machines can. So the step number one, remove humans from the process. And the way how we normally remove people from the process is by using some form of workflows or pipelines or something like that, right? Some form of execution, automatic or automated execution of steps. We need also to make things fully traceable. We need to know at every single moment what is the desired state, what is what somebody wanted to be the state of some environment, of production or integration or testing or whatsoever. And to do that today, hardly anybody is disagreeing in a way that we are doing that, accomplishing that through some form of GitOps. So that would be the second ingredient I'm going to add to the mix today. If you want to make things secure, we need to deny access to the cluster to everybody. And realistically, when you look at the tech scene today, when you see what we're having, there is no good reason why people should have access or anybody should have access to the cluster, except in case of a disaster, something terribly wrong going on. Now, when I say, hey, nobody should have access to the cluster, normally people freak out because the first impression that people have on the thought that nobody should have access to the cluster is that everybody's lives will be more miserable, that everybody will have to start opening 57 Jira tickets to get something done. But that might have been true in the past. That's not how we work today anymore. And one of the tools or one of the processes that can help us with that, denying everybody access without being less productive, is, again, GitOps. We also want to reduce blast radius. And what I mean by that is that if you're deploying frequently, and I hope that we are, probably you're deploying like once a day at least, right? You want to have some form of progressive delivery, something like canary deployments or some of the variations of that. For a simple reason that if you're deploying frequently, and something goes wrong, and something will go wrong. Actually, something will go wrong even if you don't deploy frequently. Anyways, when things go wrong, we don't want to affect 100% of the users. We want to affect maybe 5% or 2% or 10% of the users and figure out, based on their feedback, that there is something wrong and be able to react. And the reacting can be either rolling forward, rolling back, whatsoever, right? But anyways, long story short, progressive delivery is a must for what we're doing today. And at the same time, that will solve the problem of automated rollbacks when that is possible. And it is not possible, really, in many of the cases. And finally, everything I will be doing today needs to be secure one way or another. So what I'm going to do, start doing in a few minutes, is mostly hands-on demo. And we're going to use Argo workflows and Argo events for pipelines and workflows. The reason for Argo workflows and events is because everything is in Kubernetes today, and Argo workflows might be the only real tool really designed from scratch, from day one, to be Kubernetes native together with Tekton. So those are probably the only two options you have today. For GitOps, Argo CD, everything I will show you equally applies to Flux. They're more or less equally good. There is no better or worse among them. I just got to make some choice. Progressive delivery, again, it will be Argo rollouts, even though almost exactly the same results you would get with, what is the name? Flagger. And finally, to make things slightly more secure, it's a short demo, so I cannot really go deep into security. We will be using sealed secrets while still applying GitOps through Argo CD. And if I didn't mention GitOps, that's one of the things we will do today as well. So let me share my screen and show you actually what will happen and how will that happen. If I find the button to share my screen, here we are. Sharing my screen. Let's do a demo. Demos always fail, so bear with me if something goes wrong. Now, let's start with GitOps, right? How would we apply GitOps? And that's relatively straightforward because to apply GitOps, you just need to install some tool. You need to do things that you were already doing for years and years and years. And what I mean by that is that you're all already storing all the code in Git, and you're all writing code to define everything. You're not pushing buttons. You're not going to AWS console and saying, "Yeah, I want a new something." You're creating, I don't know, Terraform manifests, Kubernetes manifests, Helm charts, customize, whatever you're doing, right? The point is that everybody already accepted that everything is defined as code. If everything is defined as code, then everything is stored in Git. And if everything is stored in Git, then actually GitOps is very easy, extremely easy, actually. And just as a demonstration, I have here, I'm inside of a Git repository that defines, actually, let me confirm, yes, that defines all my environments, production, staging, what's and what. And if I show you the directory production, you will see that all I did basically was place some manifests in that directory, and they're showing me, they're defining Argo CD, they're defining my applications, they're defining rollouts, workflows, Istio. I'm using Istio, by the way, Prometheus, sealed secrets, and so on and so forth. So all I basically did was create a directory in a Git repo saying, hey, that's where the manifests are. And if I show you one of those, which is, for example, this one, it's very, very simple manifest saying, hey, you know what? This is the Git repository that contains the full definition. This is just a link. I'm not showing you here the full definition, but it tells the system, hey, this is the repository you should monitor. It could be anything. This is the directory, that repository. Make sure that whatever is in my cluster is always the same as what is in head, basically in the top commit of the master branch, and do all those things automatically, right? Relatively easy, relatively straightforward, only a few lines of YAML, not much more, additional YAML, right? And there is, as a result of all that, of me putting, telling the system to monitor this directory in this repository and defining all those applications, I'm getting something like this, right? This is the UI of Argo CD, showing me, hey, okay, so I actually already synchronized all those things. Some of them are out of sync because I was too lazy to set it up properly. But anyways, that's your whole system. You did not install any of those things. You did not, me. I did not execute kubectl, customize. I do not actually necessarily even have access to my cluster for the purposes of this demo. Everything is just always synchronized, right? Now, if I go back to, let me just change my screen. Okay, cool. Now, that kind of part handles GitOps, and I will go back to GitOps in a second. Now, the second part that I need to figure out how to do, if I'm going to automate everything, is somehow to create events. And by events, I mean something should happen when something happens somewhere. For example, the most typical one that everybody uses would be events based on activities in Git. So it would be a typically webhook that is firing something, notifying some process in your cluster, and then that process is doing something whenever you make some changes to Git. That's something those are the things that we all know forever, right? But it can be many other things. I would normally have events that are triggered whenever something is changed in my cluster, and then some other processes would do something, or whenever I push something to a registry, or when I do this, when I do this. Actually, not when I do. I don't do anything except push into Git. Whenever something happens somewhere. Now, a simple example of how we can handle the events would be this YAML that here we are, event sources, which, unless you're scared of YAML, should be relatively straightforward. And it says, hey, there is an event source, meaning that events happening somewhere, and those events are happening, in this case, in GitHub, right? It could be many, many, many different other event sources. And since it is GitHub, I'm telling my system, hey, there is this repository owned by this person or this organization. You should go to that repository. You should create a webhook. I'm not going to do that. And that webhook should trigger an event on this location, which is the cluster that I'm using right now. And that's about it. Just trigger a webhook. This definition does not know who will do what. And this is very important part. This is about decoupling things. This is just about being able to receive events and not really caring and not really thinking much about who is going to listen to those events. Because if you start coupling those things, really events stop being events. And then we have a companion for that, which is this one, production sensors. Now, this is a second process or a separate process that says, hey, if somebody, and this is going to be a long one, if anybody triggers an event, if somehow, magically, an event called, where is it? Event called Argo Combined Up reaches the cluster somewhere, and somebody somehow captures that event, I want to be notified. And if I'm notified, I'm going to execute, in this case, continuous delivery or continuous deployment pipeline, or pipeline or workflow. And that pipeline is defined here fully, right? So this is a relatively straightforward pipeline that says, hey, so whenever somebody triggers an event, whatever the event is, execute a pipeline, and that pipeline should build my image. Here it is. And it should build an image using a template defined somewhere. And that template is called build Kaneko Git. I will show you the template in a second. And a couple of parameters. And those parameters are gathered from the event. I'm just specifying them here. And once the image is built, promote to staging. Now, promotion to staging is a bit different than what most people tend to do, right? Majority of people, when they say, hey, I want to promote this release to this environment, to that environment, the first association is, hey, your pipeline should execute kubectl, or it should execute customize, or it should SSH somewhere, right? But remember, I do not have access to my cluster, and neither the tools I'm using have access to the cluster. So this pipeline has no access to the cluster whatsoever. Cannot really deploy anything. What it can do is that it can modify the Git repository I showed earlier, right? It can go to Git repository, push some changes there, and letting Argo CD pull those changes and do something. And in that way, everything is always recorded in Git. We have full history of desired states ever, always, till the end of time. And since Argo CD is having pull mechanism, again, nobody can access the cluster, should access the cluster. Anyways, that will promote to the staging environment by changing the contents of a repository, some repository, and later on it will promote to production, again, by changing to the Git repository that defines production, and then it will run some tests. Actually, this is a simulation of tests. Now, The order, all those things are running in parallel. All those things are starting immediately, and they're independent of how they're defined, the order of how they're defined. Like, I'm not going to really promote to production before testing. And to avoid, to make sure that everything is somehow in parallel, but yet running in specific order, we have dependencies. Like, hey, testing cannot be executed before something is promoted to staging. And let's see another example. And testing cannot run before. Where is it? Yeah, text functional cannot run before testing is executed, and so on and so forth. Okay, so those are the pipelines, right? If you're used to Jenkins, basically this similar logic in a way how we define, just very, very different in how it works. And the previous definition of the webhook that I showed you a few minutes ago, that one created this webhook, right? So this webhook was not created by any specific tool. I mean, it is a tool in a way. Was created simply by when I defined the event. When I told my cluster, hey, you should create, you should start watching for events or receiving events in GitHub. And then this webhook was created, right? Now, let me go back there. Okay, cool. Now let's go to the application, right? And see all this thing, at least part of it in action, right? Now this is a repository of my applications, and I'm going to simulate as if I'm spending a full day or maybe a couple of hours developing something. So imagine that I'm doing that. I will not really do the development because I don't have time for that. So instead, I'm going to change something silly in the source code, which is a very silly and small Hugo application. I'm going to say hello. Hello, what is it? I forgot the name of the conference. Hello conference, right? Just making a silly change to the source code and trying to see all this in action, right? So from now on, I will be doing what absolutely every developer does. You can forget everything I said by now. Imagine that I changed my role, I changed my persona, I changed some source code, and I will add that to Git. I will commit that, and I will push that something. Now, all that is left for me, basically, as a developer, from now on, my job is done. I will get a notification on Slack, email, whatever, if something goes wrong. But if it doesn't, my job is done. I made changes to the source code. I validated them locally, and I pushed them to Git. Normally, I would create a pull request and all that jazz, but I don't have time for that because this is not such a long session. Anyways, in the background, what is happening, which is not something that I would care about looking at, but since now I'm showing you what is happening in the background, I can take a look at whether my workflows are really working. And I can do that by executing workspace, argo list, namespace workflows. Wrong namespace. Argo list -a. No, argo list -- namespace workflows. Why is that not working? It seems that I made an error in the demo. I made a mistake somewhere. Let me try to debug very quickly and see whether it's working. No, I made some terrible mistake somewhere. Let me double check why it is not working. Yep. Okay, I messed up my pipeline. Everything I said was silly because obviously I'm not capable of doing it myself. Actually, demos tend to fail, and I failed miserably. So you will have to imagine that my pipeline was working and that it was triggered. Actually, let me double check one more thing, and then I will leave you alone. I will actually not leave you alone, but I will switch to something else if this doesn't work. Ta, 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 ta. Uh-huh. That's the correct IP. Okay. We're going to skip the pipeline. Imagine that pipeline executed correctly, and that it built the binary, built the image, and did everything. And one of the things that it would do is that it would go here, DevOps Paradox Argo combined demo here. And it would, that pipeline, I'm just doing manually what the pipeline was supposed to do. It would go to this file and it would modify the contents of this file. And then I will do that manually just to show you how GitOps works. I will say 300. I think that I have this tag created. No, let's see, something that I do have. I think I have this one. It would modify this file, right? And as a result of modifying this file, Argo workflows would kick in, and this one would start synchronizing soon. Now you will see that that this was last synchronized 10 hours ago, and every 3 minutes it is checking whether there are new contents in the Git repo. And it knows that by following, you can see here the link, following this one, this repository, right? So if I just speed it up instead of waiting for 3 minutes, you can see that it already succeeded, did something. And the something that it did is, if I go to the deployment, if I take a look at the desired manifest, actually, what is going on here today with me? I messed up something big time. I'm just not sure what. This is embarrassing. I messed up the whole system. No, it is actually deploying right now, I think. What did I do? How did I do this? How did I mess up everything, whole demo? I wanted to say that this never happens, but that wouldn't be true. Staging our command up. Yeah, it will come up. It will come up soon. Anyways, I messed up the demo completely. That was horrible on my part. Last chance to double check whether it works. Clue staging, get deployments, and describe. Yeah. Okay, I definitely messed up the demo. You need to trust me that if I change the correct repository, it would be applied to the cluster, and eventually it would initiate canary deployments, and we would get something like this, where it would be rolling out from 5% to 10% to 15% to 20%, and all the time monitoring the metrics in Prometheus. And if the certain thresholds were met, it would continue rolling up, and if certain thresholds failed, it would roll back. And the thresholds are visible from here. Those are the few metrics that I defined for for this specific application that says, hey, where is it? Here it is. Go change the percentage from 0 to 10% to 30 to 50%. Wait 2 minutes between the first and second, 30 seconds between the rest of them. And while all that is happening, do some analysis. And that analysis says, hey, if something is within that 80% threshold, it's successful. If something is below 80%, it is failure. And that something is success rate, which is a simple query that says, hey, return me all, get all the responses that had 200 response code range, 200, 201, what's or not, divide them with the error rate of all the responses. So meaning all the successful requests divided by all the requests, and then you get the success rate of your requests. Simple as possible I could come up with. Or something like this that says, hey, get me the average duration in milliseconds of all my requests happening to that application, and divide it with let me double check what this does. Divide it with all the requests, and then you will get the duration of average duration of the requests. Let me double check whether this started working. It didn't. My demo totally failed. But if I didn't mess it up, it will work. And that means that if my demo failed, that I have extra minutes for questions, if there are any. If you have no questions, I can try to debug what's going on, or we can finish earlier. I know, hey, I think I was just too impatient. Let me double check. I think it's working. How silly of me was not to be. I think that's a curse of being not patient enough. Describe pod. No, I was impatient. It failed big time. Anyways, my demo failed. If you have any questions, I would be happy to answer them. If you don't, then I apologize in advance. No? Okay, then I'm going to close the session due to failed demo early. I'll give you back 10 minutes of your time. Thank you so much.